Good evening, everybody. This is Karthikeya from CSCB. So, my topic is nested quantifier from DMS. So, in this session, I will explain our nested quantifiers. So, what is nested quantifiers? Nested quantifiers is a nothing but nested quantifiers are quantifiers that occur within the scope of other quantifiers. Nested quantifiers are the quantifiers that occur within the scope of other quantifiers. Example, for all x beyond y, p of x comma y is an example of a nested quantifiers. So some of the examples or otherwise the questions are given here. So let us discuss the first one. Let L of x comma y, let L of x comma y be the statement x loves y. So so the statement mentioned x loves y means x is a variable and y is a variable. We don't know about x. We don't know who is x. We don't know who is y. So they mention x loves y. So let L of x be the statement of x loves y, where the domain for both x and y consists of all the people in the world. So the domain of both x and y will be the all the people in the world. So he's saying that use quantifiers to express each of these statements. So we have to express the statements with quantifiers. So let's go. So what is the first? So the first one. So first one is everybody loves Jerry. So here mentioned everybody loves Jerry. So everybody is not a particular person, not a particular thing. So we have to consider it as X. So other thing, Jerry. Jerry it's like it's a particular. It's a particular. Maybe we have to. Maybe it is a particular person's name, a particular insect, and we can also know, we can also consider it as a Jerry insect. So we can consider it is as a Jerry as Y. So so uh, so so here confirm that everybody should be X and Y should be Jerry. So uh, so we understood everybody loves Jerry. So how we express this statement by quantifiers means, so he mentioned, that for all x for all xl of x comma Jerry. So why x comma Jerry, right? So next second one is everybody loves somebody. What is it? Everybody loves somebody. So same thing. What I said first one is everybody is not a particular person, is upon the particular thing. Somebody also is not a particular person, is not a particular thing. So we have to consider it as x and y same. So how to express this as quantifier is for all x beyond y, L into x comma y. So coming to the third one, there is somebody whom everybody loves. Here only x, only x, only x is mentioned in this statement. In C, only x is mentioned. No, y is not mentioned. So what we say is how what is in quantifier means uh, beyond y, for all x L of x comma y. So coming to the D, nobody loves everybody. What he said, nobody loves everybody. So the quantifier is for all x beyond y L x comma y, or beyond x for all L x comma y. So let us talk another example. Let w of x comma y means that student x has visited website y. Student x has visited a website y, where the domain for x consists of all students in your school, and domain for y consists of all websites. So we don't know who is student x. So we have to consider x as all students, and we don't know what is the website. So we cannot mention the particular website. So we have to consider all the websites which we have in the internet. So express of these statements by a simple English sentence. So we have to express this sentence into a simple English. So you are given that beyond y of W of Akash Puri, comma y. Akash Puri. The student name was Akash Puri, and also and W of Candy Yoon, and another student name is Candy Yoon. Why? So what we said, right? There is a statement that both Ashok and and Cindy has visited. So there is a website. We don't know the website, so we have to mention there is a website that both Ashok and Candy has visited. So coming to the G, beyond Y for all Z of y6 is equal to David Blecher, and W of David Blecher, comma Z is to W of y comma z. So what is the statement of this quantifier? Means there is a person besides David who has visited all the websites that David has visited. So there is a person besides David. So we know that there is a person besides David who has visited all the websites that David has visited. So coming to the C, coming to the H, beyond X and beyond Y for all Z of X of X is equal to Y, and W of X comma Z is equal to W of comma Z. There is the final sentence is there are two distinct people who visited who have visited exactly the same sites. So this is the last one. Let M of X comma Y be the X has sent Y an email message, and T of X comma Y be X has telephoned Y. Where the domain consists for all students in your class, use quantifiers to express each of these statements. There is a student in your class who has not received an email message from anyone else in the class and who has not been called by any other student in the class. So is that the question mentioned that there is a student in our class who has not received an email message from anyone else in the class. So a student uh, in my class who has not received an email from anyone from my class, and who has not been called by any other student in the class. So that student did not get any emails and any phone call from uh, other student in the student class. So how we express this, uh, how we express by using quantifiers means beyond X for all Y of X 6 is equal to Y. Therefore, M of Y comma X and T of Y comma X. So the last one is every student in the class has either received an email message or received a telephone call from other students in the class. So what is the statement? Nothing but beyond X, beyond X for all X beyond Y of X6 is equal to Y, and M of Y comma X and T of Y comma X. So this is the nested quantifiers. So so this is the topic I want to. So this is the work I have done on nested quantifiers. So thank you so much.